yeah, only 4 full lessons before the cast starts. Anakin, how'd you do problem 1?
I did. Would it be 3 times 1.9? I didn't really. That's kind of confusing.
How do you find the area of a triangle? There's a formula that we always use.
Is it base times height divided by 2?
It is. The way I always remember that one is I think, okay, if I had a rectangle, that would just be base times height. And then if I cut it this way, it would make 2 triangles. So yeah, it's base times height, which is a rectangle, but then divided by 2, because a triangle is always half of a rectangle.
Yeah.
So what numbers did you put in here?
I put in squared.
You don't really need to square anything unless you're working with circles.
So would it be 3 and 1.9?
Mm-hmm. What's that become, Anakin?
5.7.
5.7 divided by 2?
I got 2.85.
That's right. What are the units?
Inches. Square.
There you go. Okay, let's get started on this one. Kai, what's the first part you found?
I guess the rectangle,
Sure.
which is 32.
Very tempting to do 32, but 8 feet would only get me this far.
Oh.
But if you wanted that whole thing, the length probably needs to be a little longer than 8 if you want the whole thing. What does the length have to be?
I guess 11.
11. Where are you getting 11?
Because the 3 feet and that's 11.
Yeah, if that's 3 and you want the whole thing, 3 plus 8 is 11. So Kai, what's 11 times 4?
44.
44. I'm willing to bet a lot of you guys were at 32. That's a tricky one.
Oh, I just didn't.
Max, how'd you find the area of the top triangle?
I multiplied the 2 feet by the 3 feet.
What's the very good. I was just going to ask you. So base times height divided by 2. What is that, Max?
3.
Yeah, because that becomes 6 divided by 2, which is 3. All right, so we got 3 for that one.
So wouldn't you just do base times height? Like 8 times 4.
8 times 4.
Wouldn't that all you be doing?
Oh, well, I cut this up into a big rectangle and then 2 triangles. There are other ways to do it, but in this way we only have to find 3 shapes. This
Yeah,
rectangle,
but the rectangle it's 8.
well, it's 8 to here.
But then 5.
Maybe I'll show you, and then you can ask me if I'm still confusing. So the 8 only is like part of the rectangle.
Yeah.
So they're like, but if I want the whole length, I have 8 for this much, and then 3 more.
Oh.
So it's 11 times 4, which is 44. Did I answer your question?
Mm-hmm.
Okay, cool. How did you find the bottom one, Aiden Coleman?
I did 3 times 3.
Which is
then divided by 2.
very good. So you got kind of a decimally one, but what is 9 divided by 2? What's that?
4.5.
You got it. I think 9 divided by 2 is 4.5. Charles, how do you find the area of the whole thing then? Sure. What did you get when you added all those? Well, that's okay. You can actually add these pretty quickly. Just add the whole numbers first, and then just tack a 0.5 on at the end, because that's the only decimal. So just add the whole numbers. What is that? 51 point what? Yeah. There you go. How about this one? So 51.5, we found the area of the 2 triangles, found the area of the rectangle, we added them all together. Next up, Aiden Smith, get me started on this one.
So in the middle, wouldn't that be 40 or would it be 100? I get confused if you add.
Oh, between area and perimeter?
Yeah.
You multiply for area.
Oh, okay. So would that be like 100 or 1,000?
Well, what's 10 times 10?
100.
Yeah. The way you can kind of tell the difference between them is with area, they want to know how many squares covers the whole thing. So you could just ask yourself, does it look like there's 40 squares covering the whole thing, or does it look like there's 100? And the way you can kind of tell is the reason we multiply length times width is because you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares on the bottom, plus another 10, plus another 10, plus another 10, plus another 10. And at some point, someone got tired of just adding 10 over and over, and they're like, oh, a faster way to repeatedly add 10 is to multiply. So that's how I remember that you always multiply to get area, because you're literally like trying to speed count how many tiny squares covers the whole thing. So you always multiply to get area. You could also count one at a time. It would just take you forever. So you got 100 there. Aiden, how did you start finding the area of the semicircle?
That one was hard for me and I didn't get it.
Do you remember the formula for a semicircle?
No, I
In the
don't.
future, look at your notes from yesterday. We wrote that down yesterday. Kyra, how do you find the area of a semicircle?
I'm not sure either.
Same thing. Are you guys like throwing your notes away? Okay. Do you have them?
Not with
Okay. Keep your notes, guys. It makes these conversations a lot more productive. Aiden.
Isn't it pi r squared?
It is. Did you remember that?
Yeah.
Okay, cool. Most people are not going to memorize it that quickly. I'm going to highly encourage you guys not to throw your notes away. Because for most people, they need to look at it like a lot of times. But if you're like, I've got them all, that's great. You got a good brain for formulas. Most of us need to look at it a bunch of times. Ava, why don't you keep going for me? What do I do?
It's 10, not flat size.
Well, I'm looking to find the area of this thing. So what's the radius of this thing? It's 5. How did you get 5?
Because I know that line is 10, I just cut it in half.
Okay. If you struggle to find the radius of that semicircle, just look at the opposite side. You could also count boxes. If this whole side is 10, that's the diameter. So to find the radius, you just want half of that. So it's going to be pi times 5 squared. All right, Ava, keep going.
5 times 5 is 25.
Okay.
This is 3.14 times 25.
We're going to use 3.14 for pi. Is that going to be a full circle or half of a circle, Ava?
That would be full, so then just divide by 2.
You are going to divide by 2, yeah. That's not a full circle, it's a semicircle. All right, Ava, I'm ready. 3.14 times 25 divided by 2. What is that?
It was 78.5 and divided by 2. I think it's 39.25.
Go ahead and multiply it out again. 3.14 times 25 divided by 2 because it's half of a circle. 30. I think it is 30 something, but what
39.25.
is it? Okay, you got it. Sorry, Ava. Okay, but I'm not done with this yet, Kai. What do I have to do?
You have to add them together.
Sure. So when you add the semicircle, which is 39.25 to 100, what do you get? Yep, that's a pretty easy addition problem. But yeah, circles and semicircles I think are by far the hardest. And then I think triangles. Max, your book's got to go away when I'm having a class discussion. Why don't you guys turn to the next page? We're going to write students will be able to. Oh, shoot. Let me double check that I've got a recording going. Okay. Students will be able to find the area of a shaded region. By subtracting. Go ahead and see how much of this you can fill out from yesterday. I'll start cold calling you guys for answers in about a minute. How do you find all of those things? See how many of those you can remember and write in the box. If you're totally stumped, you can look at your notes from yesterday, but try to write as many as you can from memory. If yours is blank, I will make sure I can call on you to help you through as many of them as possible. All right, Claire, how do you find the perimeter of a shape? Mhm.
Oh, okay. So the perimeter you add all sides.
Add all sides, put that in your box. Circumference, Max.
Circumference is the diameter times pi.
I'm going to challenge you a little bit. What if they only gave me the radius? What would the formula be if they only gave me the radius?
It would be the radius times 2 times pi.
Can you tell me, Max, why those two things are actually the same?
Because the radius is half of the diameter and circumference is, and diameter is the whole diameter.
Nice. If you can remember that if you take the radius and multiply it by 2, it's always the diameter, then you don't really need to memorize both of those. You could just, like, I usually just remember diameter times pi, and then I know that I could change it to 2 times the radius, because 2 times the radius is the diameter. Jillian, give me another one you can pick.
Guess
What?
area of a circle.
Sure. How do you find the area of a circle? Well, you know it's going to have what weird symbol in it?
Pi.
Yeah, circles always have pi in them. And then with a rectangle or a square, they always have two. Well, I'm going to give you my hint for remembering this. For the area of a rectangle, there's always 2 dimensions, length times width. So, but a circle doesn't really have length and width. So how do they get 2 dimensions into this formula? Well, it's the radius, but how do they get 2 of them in there? Squared, yeah. And that's because a circle only has really like one kind of line that you can measure. So they just squared it to get those 2 dimensions. Area of a triangle, Aiden Smith.
I'm not sure about that one.
I'm going to give you my hint again. I was showing this to Anakin because this is how I always remember a triangle. How do you find the area of a rectangle?
A equals pi.
Well, the rectangle is the easy one, right? You and I just talked about this. To find the area, you just do what times what?
What is it? Base times height.
Yep.
Divided by 2.
Well, but remember, if it's a rectangle, remember you were just doing this problem for me, I think it was right here, right? And you found the area of the square by just doing length times width. You could also call those base times height. So
Triangle would be base times height divided by 2.
exactly. Do you know why it's divided by 2?
Because it's a triangle.
And triangles are always how big compared to a rectangle? Half. So that's how I use this trick to remember that all the way through high school. If you can like remember that a rectangle is base times height, and that a triangle is like half of that, that's why you divide it by 2. So here's the highest level of 7th grade math for this kind of problem, these shaded area problems. So for the first time, I'm putting the shapes inside of each other. When the shapes are inside of each other, they will often ask you to just find the area of the shaded part. To do this, find the area of each figure and then subtract them. I actually even had one of these on the test that they gave me when they were testing me to see if I could be a math teacher. Like for some reason, the people who make tests love these problems. And I think it's because it tests so many different things. So with the compound shapes, we were finding the area and like adding them to each other. For this one, they're like, nah, I'm only interested in this weird shaded part. We don't have a formula for whatever weird shaded shape this is. I don't even know what to call this shaded region. It's just a super bizarre shape. So you can't really find it that way. But you can find the area of the whole rectangle and then take away the part you don't want. So we don't want this triangle because it's not shaded. They only want the area of the shaded part. So we're going to find the area of the whole thing and then take away the part that we don't want, which is that middle chunk. So step 1, or I'm going to call it step A, find the area of the big one. So this is the area of the big shape. the shape that kind of covers everything. Now the nice thing is that they gave me, and if you forget, they're all right here. Area of a rectangle is the base times the height. So 13 times 8, you guys will have access to a calculator. If your 13s are super good, I guess you could knock yourself out, but this one's going to be 104. Base times height is 104 meters squared. Make your notes look like mine, please. The next thing you're going to do is go, okay, I want to take away this white section. I don't want the white section. I just want to know the area of the shaded part. So we're going to find the area of the small. Now this particular thing is a triangle. So I'll go up and remind myself you can find the triangle by doing the base times the height and dividing it by 2. So base times height divided by 2. Now the height is easy. The height is very clearly 6, but I can't really see how wide this is. I don't know what the base of the triangle is. So I'm going to use that trick I taught you yesterday. Opposite sides of a shape are always going to add up to the same thing. So if this whole thing is 13, and this is 4, and this is 4, 4 plus 4 is 8. So how much more do I need this part to be to get from 8 to 13? How much more do I need to get from 8 to 13? Kimberly, what do you think? 5, yeah. 2 ways to do that. You could count up from 8 or down from 13. I know some kids like to subtract 13 minus 8, but you got to figure out that it's 5. All right, Kyra, how do I find the area of that triangle now?
By doing the base times height.
What was the base again?
What?
What was the base again?
5.
Yeah, okay, no, you're good. I could tell I was kind of being confusing there. What is 5 times 6?
30.
30 divided by 2 is?
Wait, give me a sec.
You're good.
It's 15.
Most people only have their 2's memorized up to 24 because that's the end of the times table. Kai, how do I solve this now?
You would subtract it.
Yep. So please do not add them. If you're doing these shaded parts, they want us to take away the white part. They only want to know the area of the shaded part. So when you subtract these, I think it's 89 meters squared. Make your notes look like mine. I probably should have put the rectangle problem first because most kids tell me the rectangle ones are by far the easiest because you only have to do with base times height. Jillian, how would I get this one started?
Would you
Let's find the area of the big shape.
do base times height?
What is that?
Would be 8, and the height and the base would be 10. Yeah, because
This one's actually not even too fancy with it. They kind of just tell you, like, this big shape has a height of 8 and a base of, kind of just tells you, 15. Yeah. This one didn't do any of the tricky stuff that this one did. It just told you it was 15. Use a calculator unless your 15s are mysteriously super good, which is great. It's 120. Let's find the area of the small one. Let's see. Charles, area of the small one. Yeah, they didn't even do anything fancy here. They gave you the base and the height. 5 times 3 is 15. So Charles, how do I find? That was an easy one. So how do you find the area of just the shaded region? What is that? Units, please. Good. Okay, hardest one by far. As soon as you toss in a circle, things get really decimally because pi is involved. Claire, how do I find the area of a circle? Well, actually, you know what? I'm getting ahead of myself. Let's find the area of the big shape first.
Is it supposed to be 6 and a 4?
This one's kind of weird. Let me kind
I'm
of
not
zoom
sure,
in.
Like, if it's like the to do like a
So,
specific one?
They just want you looking at that red box.
No, I know, but are those the numbers? Because they're very like. super
Oh, you
specific.
know what? I are those on your paper too?
Yeah.
Honestly, I'm not.
It was so weird.
I'm not sure what those are. Sorry. All right, so just look at that part. So what? Let's find the area of that red square. You got kind of a hard one. How do I find the area of that red square?
Base times.
Yeah, but what is the length of the base? You have to do kind of some tricky thinking. They gave you this 2. You can actually use that to figure out the base and the height.
I thought that those numbers were supposed to be. Like,
That's all right. Let me show you another way of thinking about it. So this is the radius of the circle, right?
yeah.
At the edges, I want you to notice that the radius of the circle goes all the way to the edge of the square.
Mhm.
So if this thing was down here, like if it was kind of turning like a clock, it would be 2 inches from the middle to the outside. How long would it be from the middle to the outside over here? 2 inches, because that's the radius. So how long is this whole thing?
4.
4. Do you see how that's exactly how long the square is?
Yeah.
So if that's 4,
So the area of the square is
16, yeah. And that one was kind of tricky, but you can imagine the radius kind of turning like a clock, and it can make you realize, oh, if the radius is 2, then the distance across the whole thing is 4. And for this particular problem, the distance across the circle happens to also be exactly as wide as the square is. So what? So you told me it was 16. Base times height is 4 times 4, which is 16. Okay, so I've got the square. Atticus, how do I find the area of the small circle? So we can subtract it. I just want to know the area of the red part.
Would you multiply the size by each other?
You got to remember how to find the area. So what we're taking away, because I only want the area of the red part. What you're taking away is a circle. So how do you find the area of a circle?
With radius?
Look
Or
at
circumference?
look at your brain dump at the top. How do we find the area of the circle? Area equals what?
Pi r squared.
There you go. What's the radius of this particular circle, Atticus?
4.
4 is the diameter.
So it's 2.
Okay, what now, Atticus?
Then multiply 2 times 2.
Which is?
4.
Okay. And now that everything's all simplified, I think I'm ready. What do we usually use to estimate pi, Atticus?
3.14.
All right, got a calculator?
Yeah.
3.14 times 4. I don't think we need to divide by 2 because that's not a semicircle. That's a whole circle.
It's 12.56.
12.56. Awesome. Shay, what do I need to do to finish this problem?
Subtract 16 from 12.6.
All right, go ahead and use your calculator. What is the difference between the square and the circle? That'll give me that weird red shaded area.
3.44
3.44 what, Shay?
inches
Inches what?
squared.
Yeah, area always is squared because, and again, this is how I always remembered it. When you're talking about area, you're talking about the number of little squares that covers it. So that's why you always say squared at the end. Anyway, next page. These are numbered pretty weirdly because I was just grabbing a ton of problems from a bunch of places. So you'll see it goes 1. It says whiteboards, but we're not going to do whiteboards. It says 1 and then 2 and then 3 and then it awkwardly is like C, D. So I was just grabbing these from a bunch of places. I only think we're going to finish the first page anyway, but there are no answers for this section. So if you're working ahead, I'm not going to totally stand in your way, but check your answers as we go. Let's see. Audrey, how do I start this problem here? Problem 1. Let's find the area of the big shape. What is this big shape that kind of covers everything? Like if you kind of ignore this scary circle in the middle, what's the big shape here? A rectangle. How do you find the area of a rectangle? You could say length times width or base times height. So what is the base? So we know the base is 21. But here's the challenging part, Audrey. How tall is that thing?
16.
Nice. How'd you get 16?
8 times 8 is 16.
Well, not times 8, but 8. Yeah. So if you know that the radius is 8, then the whole thing must be 16. Nice. Use your calculator, Audrey. What is the area of that big thing? Hey, Devin. Mr. Dudek also walks through doors like that. Oh, I'm sorry. I don't mean to pick on you if you're mad. Audrey, what is 21 times 6? What's that? It's probably
21
big.
times 8.
21 times 16 is going to be a pretty big number. Probably like 400 or something. 336? All right, beautiful. So this is the area of a small one. All right, Kyra, how do I find the area of the small shape here?
Wait, so I was kind of spaced out. So you got the first part.
So we got the big blue rectangle, but now we only want the blue part, so I'm going to subtract the area of the circle. So I got to find the area of the circle.
Okay.
What's the formula for the area of the circle?
Let me see.
That's okay.
It would be A equals pi r to the second power.
How can I help?
Can I go get my pencil from the Perkins?
All right, so what is the radius, Kyra?
The radius would be 8.
Yeah, they actually gave me the radius. And keep going, Kyra. What's 8 squared?
8 squared would be 4, right? Or no, that's 8 times 8 equals.
I think yes. You were actually doing something else that I haven't taught you yet. But 8 squared just means what's 8 times 8?
64.
64. Okay, that's as simplified as possible. I think I'm ready to estimate. What do we use for pi when we're estimating?
3.14.
Okay, use your calculator.
It would be 200.96. That's what I got.
Go a little slower. It should be like 180 or 190 or something. Do 3.14 times 64. What's that?
296.
It is 296.
200 point. Which rounds to 21?
Oh, I think I just misheard you, Kyra. Because let me look at it. I think you might have been right. 200. Oh, I thought you said 296, and I was like, oh, that's a little. Okay. No, but you were right. You were right. I thought you said 296. All right, Anakin, how do I solve that thing? Pause your thought.
Mr. Johnson, could I have Atticus Axel Wilson to the office for a moment?
All right, he's on his way.
Thank you.
All right, Anakin, how do I solve it?
We're still in the circle, right?
Uh-huh. This first one.
Let's do it.
You don't know what to do with it?
Oh, do you subtract those two? Or?
Yeah, but I want you to be more confident. So the reason that you subtract them is they just want this blue part. So we found the area of the whole thing, but now we're just going to take away the circle. So how do I take away the circle?
Yeah, 336. Subtract by 200.
Okay, use your calculator.
135.04.
It's what?
135.
Okay, and they want us to round it to the nearest inch, so what's that? Cool. Looks like it's 8. All right, let's try another one. Why don't you guys all try 2 on your own? If you're done early, you can do 3. But the nice thing about 2 is it's just rectangles. So find the area of the big one, take away the area of the small one, and you'll have the shaded region. If you finish early, start problem 3. But everyone should have an answer for me in about a minute for problem 2.
Is this the same we did yesterday?
It's a little harder, but so like for yesterday we like found the area of the 2 different parts and we added them together.
Yeah.
For this one, you find the area of the 2 parts and you subtract them because like they just want the area of the shaded part. So actually, why don't you jump into the one we're working on? So if they just want the shaded part, then you find the area of the big rectangle, which is just base times height, and then you take away the area of the little rectangle.
So what would I put up here? 30 centimeters? So it's
Well, you have to work it out what 20 times 30 is. And then once you get that, figure out what the area of this one is by doing 5 times 18, and then subtract those two numbers from each other. But we're going to go over it on the board in a second. I know it's like a crazy thing to jump into the middle of. All right, Kimberly, I'm ready. How'd you do 2?
20 times 30.
20 times 30 for the big one. What was that?
600.
600 is the area of this big purple shape. But then what was the area of the small one?
18.5.
You can use your calculator if you want. You got to find the area of the big one and the area of the small one and then subtract it from each other. So what is 5 times 18?
90.
90. Okay, so if I just want the purple part, how do I find that?
So you do area, pi times r squared.
You only really need to do that if you find the area of a circle. So this one, you're actually done with all the like heavy math. You found the area of this whole big thing, and then you found the area of this kind of tiny small shape. But they only want the area of the purple part. So if they don't care about the white part, we're going to subtract it. So what's 600 minus 90?
510.
510. There it is. Okay.
I don't know if these answers are right, but
There are no answers to this section. Those are for the next section. Sorry. I just tossed a bunch of extra problems in because I knew we'd need some extra practice together. These are kind of hard. All right, this one is telling me the radius of the big circle is 50 and the radius of the small circle is 36. If they just want the area of this kind of donut-like shape, you have to find the area of the big one and the area of the small one and subtract them from each other. It's literally like cutting out this middle part, which only leaves the area of the outside part. So Shay, how do I start that? How do I find the area of the big one? Well, let's start with the circle. What's the formula to find the area of a circle?
pi r squared.
Yep. Okay, what's the radius of this big guy?
50.
Yeah. This is going to get pretty big, Shay. Can you give me 50 squared? You can use your calculator if you want to. Claire, you should be writing this down. It's what? I think you just did 50 times 2. So 50 squared means you take the base, which is the big number, you take the base and you multiply it by itself this many times. So what's 50 times 50? It's a big number.
2,500.
2,500. Ava, what do I usually use for pi? Okay, go ahead and multiply those for me when you're ready, Ava. Say it again. My air conditioning's on. 7,000 what? 7,850, like exactly? Isn't that weird? Okay. I think I remember that from this morning. It's just weird that you multiply a decimal and you get a whole number. Okay. Jillian, what do I do now? Yep, let's find the area of the small one. I'll do it over here. What's the formula again to find the area of a circle, Jillian?
Area equals base times height.
Look at your brain dump again. How do you find the area of a circle?
Oh, it's area equals pi r squared.
Okay, so what's the radius of the small one? If you can shout over the sound of 6th graders apparently stampeding. Yeah, sorry, they were thumping around. What's the radius of the small circle?
Oh, would it be
Yeah. Do you see how the line they drew for 36 goes
Yeah.
just to the outside of the small one? They're telling you that the radius is. Oh, you're fine. You're going to need your calculator for this, Jillian. 36 squared is a big number. What is 36 times 36? Like that? Okay. I think we're ready to estimate an answer. What do we use for I was about to tell you. What do we use for pi? What?
3.14.
Go ahead and multiply those two. What is the rough area of the small one?
Okay. Very long number.
I'm ready.
I was gonna like say the number when I was big.
Just go kind of slowly. I'm old.
406.94.
I think it should be like 1,000, maybe like 4,000, right? Go a little slower. 3.14 times 1,296. I feel like it's many thousands.
She said
Yeah, sure.
4,000.
I need to get my ears checked. Sorry, Jillian. Did you say 4,000? Oh, man. There goes my hearing.
What did you think?
If you guys... I don't know if I've given you my old man lecture about listening to your music too loud. Have I given you my old man lecture about that? So because I used to listen to music really loud. My mom could hear me in the back seat because she could like hear my
Yeah, that's my
headphones because they were
brother.
so loud. And she'd always be like, "Turn that down, you're gonna damage your hearing." And I was like, "Old people don't know anything." Turns out it did damage my hearing, and that's why I'm being like, "I don't know what you're saying, Jillian." So when your parents tell you to turn down your music, listen to them, or you will be telling kids that you can't hear them in about 20 years. Anyway, that's my old man lecture. Old man Johnston. All right, Jillian, you're almost done. What do I have to do to get the answer? I just want the shaded part. How do I find that?
I'll write that down. You subtract, like, the big decimal
Yep.
by 7,850.
Yep, subtract them from each other. But remember, start with the big one and take away the small one. You should see one of these answer choices when you do that. Go ahead, Jillian.
Equals,
What?
it's a big number.
It is. I think it's. Isn't it 3,000 something?
Yeah, I put 3, 7, 8, 5, 6.
There it is. I think I see that.